Hello everybody and welcome back. In the previous couple of clips, we've created a basic wood material, and then we've also kind of upgraded that basic wood material by adding a clear coat layer to it. Now, both of those were non-metal materials, and in this clip, in this tutorial, we're going to be creating our very first metal material using the new Corona physical material here. Now, the material that we'll be creating is going to be this sort of weathered material that's going to be applied on our toy robot here. So this is bound to be another fun one. So let's just get straight to it. Right. So if you'll remember from the previous tutorials, the first parameter that we want you to tweak whenever you're creating a new Corona physical material from scratch. So that means whenever you're not using any of the awesomely cool presets here that can make your life easier. The first parameter that we want you to tweak is the metalness parameter. So previously we've created different types of wood materials essentially, and those were non-metal materials. But in this tutorial, we'll be creating a metal material. So we need to set our metalness mode here to be set to metal. Now, just to jog your memory a little bit here, what does the metal parameter do? Well, it essentially changes how the material works under the hood, because a non-metal material works differently than a metal material. But now that's not the only change that you'll see happening, because the UI is also going to adapt to the type of material that you're setting out to create here. If you'll remember, a metal material has different parameters that are relevant to it. So for example, an IOR parameter is irrelevant for whenever you're creating a metal material. But for example, the edge color parameter here is very relevant for whenever you're creating metal materials. Right. Okay, now if we focus our attention on the interactive render here, you can see that just by switching our metalness mode to metal, our material is starting to look quite a bit different than it was before. Now, we're still using a really high roughness value here, so our reflections are super diffuse, okay? They're super blurry, if you will. Now, if we start lowering the roughness parameter here and making reflections more, less rough, right? You can see that indeed just by changing the metalness parameter here to metal and by adjusting the roughness parameter, we're already getting a really nice looking metal material here. Now, obviously we're not going to stop here. There's a lot more details that we can still add to it. And that's exactly what we'll be doing next here. So the first parameter that we're going to tackle a bit more in depth is going to be the color parameter. Now, whenever you have your metalness set to be, the metal mode, the color parameter is going to define the reflection color for your metals, okay? So if we open up the color picker for this parameter, and if we start messing with the hue and saturation parameters in here, well, then we're essentially going to be introducing color to our color picker in here, and subsequently, to our metal material here as well, because that's exactly what the tooltip here says. The color parameter defines the reflection color for your metal. So if you want your metals to be of a different color, just come in here and set the color to whatever you want it to be. Now, there is one extra parameter in here that you'll want to pay extra attention to, and that is the value parameter, okay? So if we start lowering the value parameter here, you're going to see that our metal is going to start looking less reflective, because essentially what we're doing with the value parameter in here is we're reducing the reflection's strength. Okay, now if we up the value parameter, then we're increasing the reflection strength, and our metal material here is going to look a lot more reflective than it did before. Now, obviously you don't want to stick to extreme values here, because those are somewhat uncommon, because, what kind of metal is this reflective in the real world? But, if you're looking at the real world references of metal materials, then if you want to hit that reflection strength properly, you should adjust the value parameter in here, right? So for our material here, I think we're going to go with a value of 180, which results in this nicely reflective metal material here, right? Right. Now, what some of you did previously with the Corona legacy material, you resorted to adjusting the IOR parameter to up that reflection strength. So essentially, you went in, you set the IOR value to be this really high number, And that resulted in the reflection strength of your metal materials to be, well, a lot stronger, right? But with the new Corona physical material, and whenever you have your metalness mode set to metal, the IOR parameter is no longer available to you, right? And that is by design. And the reasoning here is that adjusting your metal materials through the IOR parameter is not quite as physically accurate as you would think, okay? Because metal materials are quite a bit more complex than that, and you can't just control them with a single IOR value. And so now a more accurate workflow is to, if you want to control the reflection strength of your metals, is you go under the base layer here, under the color parameter, and in here you tweak the value parameter, okay? Okay, so now that we've successfully defined the color of our metal material here and also the reflection strength, let's move on to the next parameter, and that is the metal-specific edge color parameter. Now, to demo what exactly it does, let's just zoom in on our toy robot here, and let's open up the edge color parameter, and let's just set it to be this bright red color. And immediately you're going to see that these grazing angles here, right, are now tinted with this color that we've selected in the edge, well, that we've set in the edge color parameter here. And so that's what this edge color parameter does. If we bring up the tooltip, you'll see that it says that the edge color parameter determines the metal reflection color for rays hitting the object at a grazing angle. And that's exactly what's happening. So again, to simplify it, these grazing angles of your material are now going to be tinted according to the color that you've specified in the edge color parameter. Now, the edge color parameter here kind of ties into the topic that we briefly opened a minute or two ago, and that is the topic where we were kind of discussing that metals are a bit more complex than what most people think of them, right? So metals have a certain color to them, right, that you can define in the base layer here with the color parameter. So this is this general color here. But then some metals have this tinting of their grazing angles that happen. Now that's not true for all of the metal materials out there, but it is true for some of them. And if you are recreating a material that has these edges sort of tinted, right? Well, that's what the edge color is there for. It mimics that real life phenomenon, if you will. So in essence, if you're staring at a material, at a real world material reference, and you see that the edges, the grazing edges are kind of tinted a little bit, well then, you just open up the edge color parameter and you tint them accordingly to what you see on that reference. Right. And so the edge color parameter, is your go-to parameter for whenever you want to control the tinting on those grazing angles on your metal materials. But the edge color is not the only parameter that does that, okay? There's another way of achieving that effect, and it's available to you if you go under the advanced options rollout, and it's right here under this use complex IOR for metals compartment, right? As soon as you enable it, you have access to all of these parameters in here. Now, this is an extremely complex and scientific way of defining how your metal materials behave, because you've got these real and imaginary values here that you need to tune, and no, that's not just a cute way of calling them. This is how scientists call these values. And you can actually get them from websites such as, for example, the refractiveindex.info, right, or similar websites. But this is a really complex way of defining that, well, complex IOR for metals, and the visual differences are really, really negligible. So we'd really recommend you to stick to the edge color parameter in here, just because the edge color parameter is also a bit more flexible, because you can visually kind of match the tint on those edges, and if you're not happy with how it looks like, and especially if your material is a bit weathered or something like that, well, you can easily just come into the edge color here and start tweaking things, right? Moving parameters left and right until you get that satisfactory result, instead of, having to resort to tweaking these really complex scientific values. Okay. Now, for our material here, we're actually going to copy the base color here. We're going to copy it into the edge color, just so now that we have this sort of base tint, if you will. But now we're just going to desaturate it a little bit, maybe a little bit more, maybe make these edge colors just a little bit more dimmer. And I'm just going off a reference that I have available to me in front of me in the real world, right? Obviously, depending on the material that you're working with, you know, you're going to come up with different values. But for us, this kind of edge color here will do fine. Alrighty then. So our robot here is kind of looking pretty cool as it is. But, you know, we could still add some more details to it. And we'll add details into the roughness and bump slots here, because those are typically the parameters that you want to, you know, introduce some maps to, so that you kind of, in the case of roughness, break up the reflections a bit. And in the case of bump, you know, you add some bump imperfections to it. So as you can imagine, we already have some maps prepared here. So let's bring over this map here, which is going to be our roughness map. And if you zoom in on it, you can see that it is just this, you know, sort of imperfection map that we'll be using here. So let's just plug it into the base roughness slot here. And immediately you're going to see that this map is pretty rough, right? And so, well, it makes our material look pretty rough. The map itself is not rough, if you think about it. But yeah, this is going to be too intense for us here. So let's go under the maps options here, and let's just mess with the mixing coefficient a little bit here. So maybe we drop the base roughness mixing amount here to 50%. This is already kind of looking cool. We're adding imperfections, but they're still a little bit too strong. The reflections are still a bit too diffuse. So let's drop the base roughness down here to a value of 20 maybe. And I think this looks pretty cool. So as you can see, we're sort of breaking up the reflections just a little bit, you know, so we're adding some details on top there. Now, I think that takes care of the roughness map here. Okay, I think this is looking pretty cool. And what we could still add to our material are some bump imperfections. Okay, so we have another map prepared here, and it's just this, well, another imperfection map. You can see we're kind of getting these really detailed bumps and bruises going, right? So let's plug this map into our base bump slot, and let's see how our material looks like. And let's zoom in also to see the details just a little bit better. And this kind of won't work for us just because the bump is way too strong. It kind of looks like this toy fell out the second story window repeatedly. You know, so let's make sure that the bump strength here is set to something a bit lower. So maybe let's set it to a value of 0.5. Let's wait for the image to refine a little bit. And this still might be a little bit too strong. It kind of looks like it fell out the window at least one time. So maybe that's one time too many. So let's set the bump to 0.2 here. And I think this looks better. So we're just adding those little imperfections here and there, right? So that the model looks like it's been bruised a little bit here and there, right? Right. Now, as you can see, with just a couple of steps here, we've created this really cool and pretty detailed metal material. And in my opinion, given the, you know, the amount of time that we spent working on it, which wasn't a whole lot, this came out pretty great. Now, could we still further tweak our metal material here? Why, yes, we absolutely could. So one of the things that we could potentially do here is we could bring in another dirt map in here, okay? And then what I'm also going to bring in is a Corona mix map, and you'll see where this is going in just a couple of seconds. Then I'm also going to bring in a Corona color shader, right? Shader slash map, however you want to call these. And then I'm going to go under my material here. I'm going to copy the color of our reflections here, right? So I'm going to copy this entire parameter and paste it into the Corona color in here. So just like that. And now I'm going to plug this Corona color into the bottom slot of our Corona mix shader. And I'm also going to plug that dirt map onto that top spot there, top slot. Now that I've done that, I'm going to adjust the mix operation. I'm going to set it to multiply. And now you can see what's happening when we're mixing these two maps together. Now, this whole Corona mix map is going to get plugged in into this base color slot here. So this is this slot right here, right? Which, if you'll remember, this slot defines the reflection color for our metals, and it controls the strength of the reflections as well. Now, just by plugging this map in here, you can see that we're adding additional details on top of our already cool looking metal material that we've created. Right now, this effect might be a little bit too strong here, so we can go into the Corona mix map here, into the mix shader, and we could adjust the mix amount. Maybe we could chop it down to 0.5. And now you can see, just how quick and easy it is to add even more details onto this already, onto the material that was already pretty cool looking, right? And what we demoed here is that you don't really need a lot of different shaders or bitmaps to get that going, right? We're just using a couple of different maps here, and look at this awesome, cool metal material that we've created here. Okay, so now, before we conclude this tutorial, there's still one more thing that we'll want to talk about here, and that is mapping the metalness parameter. Right, so our scene here has changed. Our cool little toy robot here got replaced by this cool little tea kettle here, and that's what we'll be working with here to demo how you can map the metalness parameter here. So the first thing that we'll do here, we're just going to bring in a metalness map, and we're just going to plug it into the metalness slot here. We're going to instance it in there, and immediately what you'll be able to see in the rendered image here is that certain parts of our of our tea kettle here are now metal, while other parts, are not, right? So what's happening here? Well, essentially, if you take a look at our metalness map, you can see that we have masked, certain parts out. And these are these parts here that you see that are now metal. So in the context of a metalness map, everything that's white on your metalness map is going to be metal. And everything else that's black is going to be non-metal. Okay, now, there's one important thing for you to know here is that intermediate values, so, gray values and, anything that's not fully white or fully black is going to result in the Corona physical material mixing, or better yet, blending between a non-metal and a metal material. And that's not a realistic way to go about it. So that blend is just going to be a simple blend between a non-metal and a metal material. So that's why, if you want to stick to creating realistic materials, you should have clipped values in your metalness map. So either fully white or, fully black, right? Right. Now, let's talk about the UI. So as you can see, the UI here, we have all of the parameters available to us. So non-metal parameters and metal parameters, all of them are available to us. And so how does that even work? Well, let's take the IOR here, for example. If we lower it down to 1.0, you're going to see that the non-metal parts of our material here, they have an IOR of 1.0 here. You can see the reflections, but because the IOR parameter is a non-metal parameter, it won't affect your metal parts, right? As you can see, these are exactly the same as they were before. Now, conversely, the edge color here, which is a metal-only parameter, is, if we give it a red color, is only going to affect the metal parts, and it's not going to affect the non-metal parts, right? So that's how that works. Now then, let's just reset these to their default values, and let's talk about the common parameters. The common parameters are the parameters that are common to both non-metal materials and metal materials, and those parameters are, for example, the roughness parameter, the bump parameter, or the color parameter here even, right? So if we up the roughness to 1.0 here, what you're going to see is that our entire material here now has a roughness of 1.0, right? So both the metal parts and the non-metal parts now have a roughness of 1.0. So you're probably wondering, well, how do you work with roughness then? Well, the answer is pretty simple. You need a proper roughness map. Right? So let's bring in this roughness map in here, and let's take a look at how it's set up. So essentially, as you can see, these parts here that are sort of gray, right? These are basically these bottom parts here. So these ceramic parts, if you will, right? And they have just a little bit of roughness happening, right? Then we have this wood handle here. So these are these parts here that you can see that are a bit more rougher. And then as for our metal parts here, if we compare these two maps, you can see that the metal parts should be here, here, and probably here somewhere as well, based on what we're seeing in the Metalness map here. Well, these are pretty much not rough at all, right? So what we can expect happening when we plug this roughness map into our roughness slot here is that the bottom part is going to be kind of just a little bit rough. The wood handle is going to be quite rough. And then, you know, our metal parts are going to be really mirror-like, very chrome-like. So let's plug in this roughness map into the roughness slot here, and you're going to see that that's exactly what's happening. The top part here is quite rough. The bottom part just a little bit rough. And then the metal parts almost not rough at all. And so that's how that works. You know, you need to have a proper roughness map. Now, let's also bring in a base color map, and let's plug this right into the base color slot here. So this is the slot here. This is another common slot, right? Just because if you'll remember, this slot for metals defines the reflection color, and for non-metals, it defines its diffuse color, right? So again, if we take a look at the map itself here, we see that the bottom parts here, you know, are all blue, right? And that's exactly what's happening. The wood parts here, right? They have a wood texture, so that's all looking great. And then our metal parts, as you'll see, you know, if they were colored, you know, they would have a color here because, you know, we would be defining the reflection color for them. But, you know, they're completely desaturated. But as you'll notice, they still have a certain value in here, right? They're still kind of grayish a little bit. And that is because, you know, if you'll remember, the color parameter in here has this value slider. And this value slider controls the strength of the reflections for your metals, right? So even in the base color map, you need your metals to have some sort of value, even if you want them to be completely, you know, colorless. All right, well, that pretty much concludes this tutorial. We've created our very first metal material in this one. It was for that cool toy robot. And then we've also quickly gone over how mapping of the metalness parameter works. If you stuck with us for the entire tutorial, well, you now know the basics of creating metal materials with the Corona physical material. So that's it for this one. And in the next tutorial, we'll be covering creating some awesome non-metal materials again. So we'll see you there.